Hello and welcome to MLOps Minutes. In this video, I'm going to take you through the entire project organization and workflow. The idea is not to understand everything in detail, but really to give a global overview. So you've cloned the project, and in this project there are three main directories. The first important directory is train, which contains all the code associated with the drive. And here you'll find subdirectories, each corresponding to a specific workflow task. This training will be executed in Azure ML, and each directory corresponds to a box here in Azure ML. Then there's the production directory, which will contain our API code and our web app code. And finally, important directories include the packages directory, which will contain Python packages, the common code between training and production. Remember, if we need to update the library that extracts images from PDFs, we'll have to retrain our AI with this new version of the library and potentially new code, and also deploy this new AI in production with this new package, because in production we actually receive PDFs and extract the images. Otherwise it doesn't work. So in the Git workflow we're going to work in GitOps mode. The idea is to ensure that our main branch is always producible. So how do we do that? What happens is that we'll have a Kanban available. And in this Kanban, we'll find different cards. And if I want to work on them, I'll assign them to myself. Once I've assigned it to myself, I can work on an isolated branch in Git that I've created. And when I'm happy, I can create what's called a pull request, a validation request. And what happens? Well, my colleagues will be able to see the changes I've made to the code. And the good thing is that we'll be able to engage in an exchange to improve code quality. The good thing is that I'll be able to learn from this, and so will my colleagues, and we'll be able to standardize the quality of the project. So a quick word here, why are we working in monorepo Git, or even the web app in it? What's going to happen is that we'll work as a team focused on one product, meeting user needs and the customer experience. And by working this way, web designer, data scientist, developer, what happens is that with one card in the Kanban, i.e. on my board, I'll be able to associate it with a pull request. Imagine that my card has an impact on my web part, on my train part, on my production part. I'll be able to visualize it. And when I go back to the main branch, I'll be able to see all the code associated with this modification request. In addition to all these validations here, for example, I've modified code that affects the common package. I'll be able to see that it affects the production part and the training part. There will be a series of validations involved in continuous integration. What is continuous integration? It's a set of tasks running in the cloud, not on my computer, but elsewhere, that will enable a series of automations to take place. What happens in this one? We use GitHub Actions. In GitHub Actions, by default, you have to place YAML files in the .github workflows directory with this particular attack where you can chain commands, in this case bash. Let's go into more detail to see what happens with each pull request. There's a global workflow at work every time. There will be tasks running in parallel with code quality control on my JavaScript, on my Python, we're going to build my web app, my web application. Here there's a sequential workflow where I'll run unit tests on my common Python packages. We'll build these packages and even publish them in pip, the package manager in the Python cloud. We'll then be able to retrieve these packages and run the unit tests on my little boxes in the training section. We'll tag my commit. Then we can trigger the training in Azure ML. In other words, my little boxes will run. And as output, I'll get two outputs. Firstly, my generated model, which will be published in a registry model offered by Azure ML, and a data set that will enable me to test my ISO production API environment. Once I've done that, once my entire pipeline has been generated, I forgot to mention that you shouldn't be afraid to replay each little box, because if no input or output has been modified, Azure ML won't replay it. Azure ML won't replay it, it'll just take the output directly. This saves a lot of time. In the output, we'll retrieve the model version. We'll be able to build our Docker, which hosts our API and exposes our API. And we'll be able to deploy this Docker on an integration environment that's a copy, that's ISO production. And finally, we can run integration tests on it. So what happens with these integration tests? Well, in training, when we train a model, there are generally three sets of data. We'll have a train set, a test set, used to train the model, and a validation set, which is a set that the model has never experienced, enabling us to validate that the model generalizes correctly on data it has never seen. We're going to reuse this devalidation set here for integration testing, and we'll also validate that we have exactly the same responses and outputs as in training, which allows us to validate that there are no code diffs in the training and production pipelines. And that's great. We'll even go one step further. Remember the Bermuda Triangle, where prediction quality is concerned, response time and infrastructure cost? We'll be able to validate these 3 points with every pull request. And that's great, because the principle, the grail of MLOps, remember, is to be able to deliver with as little action as possible. What's great about this is that with every code modification, with every modification request, we'll be able to say, am I able to put my code in the main Jet branch? And do I have the peace of mind to say, yes, this code can go into production? Thank you very much, and see you soon for more videos.